Hey guys, it's Rishi once again, and today we're going to be going through a Mathematics Non-Calculator Paper 1 Higher Tier Edexcel paper. And now, as you've seen my previous video on the foundation papers and the topic papers, this is going to go through the same structure where we'll be focusing on each individual question in detail. I won't go through the entire topics just because that would take a very long time, but I will be focusing on each question in detail. So let's get started. Amazing. So question number 1. The diagram shows a right-angled triangle. So we need to work out the size of the smallest angle of the triangle. So the first thing we're going to simply do is by understanding that angles in a triangle add up to 180 degrees. So the first thing we're going to do is add up all of our angles and variables and equal that to 180 degrees. So we start off by going with 7x plus 5x plus 18 plus our 90 degrees, which gives us 180 degrees. We're then going to collect our like terms. So 7 and 5 gives us 12x, and 18 and 90 gives us 108, and that equals to 180. And then we'll go ahead and take that 108 over, so minus 108, minus 108, and we now have 12x, which gives us 72. We then make x the subject by simply dividing both sides by 12. And we now know x equals 6. So now we found out the value of x. Let's multiply this out with our angles to see which one is the smallest. So again, I'll go ahead and multiply this out by our 7. So 7 times 6 gives us 42. And then I'll do it with a 5x plus 18 and substitute that in. So that's 30 plus 18, which gives us 48. And we know our third angle was 90. So overall, the size of the smallest angle that we know is 42 degrees. And that is your 3 marks in the bag. Amazing. Let's go over to question number 2. So a box exerts a force of 140 newtons on a table, and the pressure on the table is 35 newtons. So we've now been given our formula, which is pressure equals force divided by area. And we're just going to simply go ahead and substitute all of these values. We know that we're going to be starting off with area, so we need to make A the subject. So that's P equals F over A, but now we need to make A the subject. So again, I'll take A to the other side and I'll simply swap it with P. So now we have F divided by P, and then I'll go ahead and substitute my values. So that gives me A equals force of 140 newtons divided by 35, which then gives me 4. So now I know that the area is 4 meters squared. And let's move over to question number 3. So this is a probability question, and we have counters red, blue, green, and yellow in a bag. And we've been given the probability of our red and yellow counter. So the probability of picking a blue counter is now the same as the probability of picking a green counter. And we know probability is out of one whole. So what we're going to simply do is add our red and yellow to 0.24 and 0.32, which gives you 0.56. And then we subtract that from one whole, giving us 0.44. And now that they've told us that the blue counter and the green counter is the same, we can simply go ahead and divide that by 2. And we then now know that our blue and green counter are both 0.22, and we can go ahead and fill out the table, and we've now got 2 marks in the bag. However, question 4 is slightly different. This is where we need to work out the total area of the pattern. So we have 2 values here. We've got 11 centimeters and 7. So let's take a look at how we can find out the area of these identical rectangular tiles. So number 1, we know they're identical. And we know that the rectangles means that the opposite sides are the same. So let's break this down. So what makes up 7 centimeters? We've got the length here and we have the width. And likewise for the 11 centimeter, we have 2 lengths and 1 width. So let's go ahead and use algebra to work this out. We've got the length plus the width giving us 7 centimeters. And we have 2 lengths plus 1 width equals 11 centimeters. So let's now try to use our simultaneous equations to understand what the length is and what the width is. So what we're going to simply go ahead and do is go ahead and subtract equation 1 from equation 2. So again, 2L take away L will give you L, and W take away W will give you nothing, and then 11 take away 7 is 4. So that now shows that the length is 4 centimeters. So now if the length is 4 centimeters, let's go ahead and substitute that in. So the length is 4 plus the width, which is 7. So if we subtract this by 4 and subtract this by 4, we know our width is now 3. So we've got our two values, and all we need to simply do is go ahead and work out the area of one rectangle and then multiply it by 4. So again, we've got 4 times 3, which gives us 12. And then we have to multiply that by 4 because there's 4 rectangles, and that gives us 48. So we now know that the total area of this pattern is 48. And that's because we've got 12 as our area in each rectangle. I hope that was clear to understand as to how we worked out both the length and the width before multiplying them out. But let's now dive into the next question. So the diagram shows a sand pit, and the sand pit is in the shape of a cuboid. And she wants to fill the sand pit with sand, and a bag of sand costs £2.50. And we now know that there's 8 litres in each bag. So Sally has said that the sand will cost less than £70. So let's go ahead and prove why Sally is wrong. So we know we've been given a cuboid, and we know the volume of a cuboid is simply length times width times depth. So we can go ahead and multiply our figures here, which again gives us 240,000 centimeters cubed. And we know 240,000 centimeters is equivalent to 240 liters. So that means we would need 240 liters of sand. And because there is 8 liters of sand in each bag, we're going to simply go ahead and divide 240 by 8. So we know 24 divided by 8 is 3, and then we can add that 0, which means we require 30 bags. And because each bag is £2.50, let's go ahead and multiply that out. So 30 times by £2.50 gives us, so again, 30 times 2 gives us 60, and 30 times a half gives us 15. If we add that together, we now know it's £75. And because Sally mentioned that it would cost less than £70, we know Sally is wrong. Okay, let's move over to question number 6. So 4 friends each throw a biased coin a number of times. And the table shows the number of heads and the number of tails each friend got. And the coin is to be thrown one more time. So which of the 4 friends will get the best estimate for the probability that the coin will land on heads? So in order to answer this question, we need to find out the one person who's received the most heads. And in this case, we see it's Sharif. So out of the 4 friends, our answer will be Sharif. And the reason being is that he's received more trials, so it should be much closer to the actual probability. Amazing. However, part B states that with this coin, you are twice as likely to get heads as tails. So again, let's go ahead and add the number of heads that we have, which will give us 300. And then let's add the number of tails, which gives us 100. So by saying that, our answer is simply no. And the reason being is that we've got 3 times heads than tails. So it's 3 times as likely to get heads than it is to get tails. And then part C states that the coin is to be thrown twice. So using all the results in the table, work out the estimate for the probability that the coin will land heads both times. So we know it's 300 heads and there's 100 tails, so it's out of 400. So we can simply simplify 300 over 400 to 3 over 4. And because the coin is to be thrown twice, we're going to simply multiply it by itself again, which gives us 9 over 16, and that is our final answer. So the estimate that the probability that the coin will land heads both times is simply 9 over 16. So we've got the first time, which is 3 over 4, and the second time, which is 3 over 4. And if we get the product of those, that gives us 9 over 16. Amazing. Let's now go over to question 7a. And this is now asking us to write down the exact value of cos 30. The rule that I give to my students is to follow the hand method, where you start with sin from 0, working your way up 1, 2, 3, and 4, and then cos starting from your pinky, going all the way down to 3, 2, 1, and your thumb being 0. And at this point, 0 is where you have your degrees, then 1 would be your 30 degrees, 2 will be your 45 degrees, and then so and so. And then you'd have to divide your answer by 2. And remember, this is all over a square root. So let me actually go ahead and give you a visual representation of this. So now if it's asking us for cos 30, so we now know that cos 30 is going to be square root 3 over 2. So we can simply go ahead and write square root 3 over 2. And then for part B, it says, given that sin 30 equals 0.5, work out the value of x. So we're going to simply go ahead and highlight our sides. We know that 12 is our h, hypotenuse. We know opposite 30 degrees is our opposite. And then finally we have A, which is our adjacent. So we're going to go ahead and write sin 30 equals, so remember with sin it's so O divided by h. So we'll go for x divided by 12. And then we need to go ahead and make x the subject. So we've got 0.5 equals x over 12. And then we take the 12 over. That divide becomes a multiplication. So we go for 12 times 0.5 equals x. And we can simply see that if you multiply 12 by a half, you're just simply halving the number. So half of 12 gives you 6, and that is your answer. So I hope that was clear. And before I move on, please take a look at this image, just showcasing how you can practice and remember this table in your head so you don't need to rely on a calculator, especially as this paper is a non-calculator paper. Okay, wonderful. Let's go over to question number 8. So the mass of Jupiter has been given to us, and we're also aware that the mass of Saturn is 0.3 times the mass of Jupiter. So to work out the estimate, we're going to round 1.899 to 2. And then we're going to go ahead and multiply this. So we're going to go for 0.3 multiplied by 2 times 10 to the power of 27. Well, we know 0.3 times 2 is 0.6. And then again, we go ahead and multiply 0.6 by 10, because in order to get an answer in standard form, your answer always has to be between 1 and 10. So that gives me 6 times 10 to the power of 26, and that is my final answer. So remember here, if you're answering in standard form, the answer must be between number 1 and number 10. Hence, I had to multiply 0.6 by 10. And then finally, it mentions given evidence to show whether your answer is an underestimate or an overestimate. Now, because I rounded up, it's simply going to be an overestimate. So we can write that down. Amazing. That's your 4 marks in the bag. Okay, question number 9. So this is now around a basketball team, and we know that at the end of the 11 games, the score was 33 points, and that's your mean score. And then at the end of the 10 games, their mean score was 2 points higher, which again we know is going to be 35. So Jordan says Walkden Reds must have scored 13 points in their 11th game. So now, is Jordan right? Let's have a look. So mean is your average. So in order to get the solution for this, we need to work using the inverse method. So I'm going to simply go ahead and multiply 11 by 33, which gives me 363. And then I'm going to multiply by 10 by 35, which gives me 350. We're then going to go ahead and subtract this, and that gives us 13. So again, Jordan states that they must have scored 13 points in their 11th game. And again, we know, yes, he is right. And our answer is 13. So yes, followed by 13. Okay, question number 10. So now we've been given a bag which has red counters and yellow counters in there. And we know that there are 30 yellow counters in the bag. And they've given us a ratio of 1 to 6. So how do we go ahead and work out the number of red counters in this bag? Well, what we do know is for every red counter, there are 6 yellow counters. So now, if we have 30 yellow counters, we know in order to get from 6 to 30, we need to multiply this by 5, which means I will then need to multiply 1 by 5, which will give me 5. So now I know the number of red counters in the bag are going to be 5. But now Riza puts some more red counters in the bag. And the ratio of the number of red counters to yellow counters is now 1 to 2, which means for every 1 red counter, we have 2 yellow. So they're asking how many red counters does Riza put in the bag? As they are now putting more red counters, we know that the yellow counters are going to remain the same, which is going to be 30. And because our ratio is 1 to 2, that makes our red be 15 because it's a half. And because we already have 5 red counters, we can simply subtract this in order to get our answer, which is 10. So we now know that Riza put 10 more red counters into the bag. Okay, let's go for question number 11. So write down the value of 125 to the power of 2 over 3. So it's a 2-step method here, not so challenging. So the first step, we need to go ahead and cube root 125 as 3 is our denominator. We're then going to go ahead and get our answer, which is 5. And then second step is going to be to square it as we have 2 at our top. And that gives us 25, which is our final answer. So again, you always cube root or square root, whichever number you get as your denominator, and then you square your numerator. Wonderful. Let's now dive into question 12. So again, this is a problem around your distance, speed, and time. We can instantly see that we've got an average speed of 50 miles per hour for the first 3 hours. And then we're told that Sean drives 150 miles to get to Gretna Green, and his average speed is 30 miles per hour. So I'm going to simply go ahead and draw out my triangle here and have distance, speed, and time. And Sean says that my average speed from Manchester to Gretna Green was 40 miles per hour. Is Sean right here? Let's take a look. So we'll take a look at the first part now. And in the first part, we know the speed is 50 and we know the time is 3. So now in order to work out our distance, we need to simply multiply our speed and our time. So now we know that's 150 miles. We then go for our second part, and our second part states that the distance was 150 and our speed was 30. So in order to get our time, if we follow the triangle on the top right hand corner, we're going to simply divide our speed by our distance. So that's 150 divided by 30, which then gives us 5. So that's your 5 hours. And then we need to calculate our total distance, which in this case was 300 miles. So we'll go ahead and have total distance and our total time, which again was 5 hours here and 3 hours in the very beginning, which gives us 8 in total. So we need to work out the average speed and to see if it is really 40 miles per hour. So again, in order to calculate speed, we need to divide our time by our distance. So we'll have 300 divided by 8, which in this case, we can simplify to 150 divided by 4, which then will give us 37.5. So Sean did mention that the average speed was 40 miles per hour, but we now know that Sean is wrong because we've got 37.5. So we can say wrong because it was 37.5. So I hope that was clear as to how we can work with our distance, speed, and time, and work with our problem-solving questions to get our final answer. Okay, question number 13. So again, this is making a variable a subject. So let's go ahead and start off with simply taking the square root to the other side. And that gives us m squared equals k cubed plus 1 over 4. We're then going to multiply both sides by 4. And we're left with 4m squared equals k cubed plus 1 before taking the minus 1 over to the other side, which gives us 4m squared minus 1 equals k cubed. And then finally taking the cube over to the left-hand side, which then gives us 4m squared minus 1 cube root, which will equal k. So again, from the beginning, what have we done? we've gone ahead and simply taken our divided by 4 over, which gives us 4m squared. We've then gone ahead and taken our plus 1 over, which gives us minus 1. And then we've gone ahead and taken our cube over, which gives us cube root. So overall, our answer will be k equals cube root 4m squared minus 1. Let's now dive into question 14. So again, this is where we have our algebraic fractions and we need to solve to find the value of x. Okay, so the first step is going to be to make the denominator the same. So again, let's go ahead and multiply this entire fraction by 2 and this entire fraction by 3. So we know 3x times 2 gives us 6x. And then again, we'll have 3x minus 2 over 6x, which equals 3. Now we've gone ahead and done that, we can simply merge our fractions into 1. So expand our brackets, which is 2x plus 4 plus 3x minus 6 over 6x, which gives us 3. Before finally collecting our like terms, gives us 5x minus 2 over 6x, which equals 3. Before then taking that 6x over, so we've got 5x minus 2 equals 3 times 6x. So we now have 5x minus 2 equals 18x. And then again, collecting like terms, so bringing that 5x over. So we now have minus 2 equals 13x. So let me now write that out again. We've got minus 2 equals 13x. And now we need to make x the subject. So what am I going to simply do? We know that minus 2 equals 13 multiplied by x. But now this multiplied is going to become a division. So we divide by 13 on both sides, which gives us minus 2 divided by 13, which gives us x. So our answer is minus 2 over 13. Spectacular. Okay, over to question 15. So this is where we need to show that this quadratic fraction can be written in the form of ax plus b over cx plus d. So what am I simply going to do? I'm going to go ahead and factorize both by numerator and by denominator. So I'm going to take on the AC method, where we simply multiply a by c, which in this case is 2 times minus 5, giving us minus 10. I then need to find two numbers that multiply to give me minus 10 and add to give me minus 3. So again, I'm going to list out my factors, which is going to be minus 5 and 2, because minus 5 plus 2 gives me minus 3. And then I'm going to put them in my brackets. So we'll have 2x minus 5 and 2x plus 2. Before again dividing this by my coefficient, which in this case will be 2. So we know 2x minus 5 cannot be divided by 2, but 2x plus 2 can. So again, will equal 2x minus 5. But we know that 2x divided by 2 is x, and 2 divided by 2 is 1. So that gives me x plus 1. So now that's my numerator done. And I'm now going to do the same thing for my denominator. So again, I'm going to multiply my x by 5, which gives me 5. So again, we'll go 1 times 5 equals 5. And then I need to find two numbers here that multiply to give me 5 and add to give me 6. And that again is going to be 5 and 1. So again, our coefficient is x. So we're going to say x plus 5 and x plus 1. And as we can see, we have our x plus 1 both in our numerator and our denominator. So we can simply cancel them out. And then again, write out what we're left with. And that again is going to be 2x minus 5 over x plus 5. And that's how you can simply write your quadratic fraction in the form of ax plus b over cx plus d. I hope that was now clear. Let's move over to question 16. So we've got 4 different proportionality relationships between x and y here, and we need to match each graph with the below statement. So the first statement states that y is directly proportional to x. And so we would simply write this out as y equals k multiplied by x. So again, if we take a look at this, this would give us d, the reason being that this is a linear graph. So any change that is made on x will be reflected on the y-axis. We then go for the second one, which states that y is inversely proportional to x. And again, that would be represented as y equals k divided by x. So remember, this can now either be between our a or our c. But again, this would be a. So we could write this down here. And then the third one states y is proportional to the square of x. And again, the way to remember this is a happy face. So x squared is always a happy face. And then we can write that down here. And again, this will be written out as y equals kx squared. Before finishing off with the final one, which states that y is inversely proportional to the square of x, which again would be your c, and that would be y equals k over x squared. Okay, let's move over to question 17. So in this question here, this is about the topic congruence. So we've been told that P to Q is the same as P to R. So we can simply go ahead and write our points here so that P to Q is the same as P to R here. And we've also been told that S is the midpoint of PQ and T is the midpoint of PR. So we then need to prove that the triangle Q to T to R is congruent, or you can say the same as R to S to Q. So what's the first thing we need to do here? Well, the first thing we can write is that QS is equal to TR, and that is because they are both half the length of your P to Q and your P to R. So now we've gone ahead and written that down. We now know that QR is then common to both triangles, so that makes it an isosceles triangle. So now that we've gone ahead and written that out, as we know that P to Q is equal to P to R, therefore we now know that PQR will be equal to PRQ. And so therefore that proves that QTR is congruent to RSQ. And again, that would be seen as our side angle side. And then again, that would be your Q to T, which is your side. You have your angle, which is T, and then your side T to R. And likewise, we can do the same thing from R to S, which is our side, and our angle S here, and then our side Q to S, or even S to Q. Okay, let's now move over to question 18. Now this is a question around working out the total surface area of a solid hemisphere. So what's the first thing that we need to do here? And that is to calculate the volume of the hemisphere. So I'm going to just write volume of H for hemisphere, and I'm going to simply write down that it's a half of 4/3 pi r cubed. And that's because a hemisphere is half of a sphere. So I'm going to go ahead and multiply out my fractions, which again gives me 4/6 or 2/3. So now I can simply write down 2/3 pi r cubed. And now I've written that out, I know that the volume is 250/3 pi. So we'll write that out and we'll equal this to 2/3 pi r cubed. And then I'm going to go ahead and make r the subject. So solve for r. So I'll go ahead and simply cross out my pi and my 3. And that then leaves me with 250 equals 2r cubed. And then I'll divide both sides by 2, which gives me 125, which equals r cubed, before simply taking that cubed over, and r equals 5. So that's my part 1 done. So part 2, what do I need to do? So we now need to calculate the total surface area of the solid hemisphere. So remember once again that a hemisphere is half of a circle. So I'll go ahead and draw out my hemisphere. And again, my hemisphere is made up of my circle, which its area is going to be pi r squared. And then we're going to go ahead and write a half of our 4 pi r squared, which is going to be 2 pi r squared, or simply a half of 4 pi r squared, as shown in our surface area here. So we can simply draw a line to that here. So now that we've got that, let's write our surface area equals pi r squared plus 2 pi r squared, which gives us 3 pi r squared. And now we've got that, we can substitute our radius. So we'll go for 3 pi multiplied by 5 squared, which is equivalent to 25. And that now gives us 75 pi. And as the question is now asking us for the answer in a multiple of pi, we can simply go ahead and write 75 pi. So I hope that was clear. Let's now move over to question 19, which is around the surds. And again, this is where we need to simply simplify this fully. So again, I'm going to go ahead and work with my brackets. We know 6 times 6 is 36. And we know 6 times root 5 is 6 root 5. And then we get minus root 5 times 6, which is minus 6 root 5. And then root 5 and root 5 gives us a minus 5, because we've got a minus just at the beginning there. And then we can go ahead and simplify this. Again, we can cancel our 6 root 5s, and we've got 36 take away 5, which gives us 31. And that's all over root 31. So now we've got root 31. And that's your step 1 done. And then for step 2, we need to simply go ahead and rationalize our denominator. So again, we've got 31 over root 31. We'll times both the numerator and denominator by your root 31. And then again, that gives us 31 root 31 over 31. But we can go ahead and cancel out our like terms, and we're left with root 31, and that is our answer. Marvelous. Let's now move over to question 20. So this is a question around proof, and we need to use algebra to find the difference between the squares of any 2 consecutive integers. So again, I'm going to go ahead and get n and n plus 1 as they are my consecutive integers. And now we need to make sure that the squares of these consecutive integers are equal to the sum of these 2 integers. So again, let's go ahead and square n plus 1 as well as subtract n squared from this. So again, I'll go ahead and expand n plus 1, and that will give me n squared plus n plus n plus 1. So n squared plus 1n plus 1n plus 1. So again, in total, that will give me n squared plus 2n plus 1. And then we have to subtract our minus n squared from that. So I'll simply write minus n squared and draw an arrow from this. So now you know n squared to take away n squared is going to be left with 2n plus 1. And now the sum of n and n plus 1 also has to match 2n plus 1, because it mentions this in the last part of the question. So let's go for our sum, and that's going to be n plus 1, which again is going to be what we started off with, n from here and n plus 1 here. And that gives us 2n plus 1. Therefore, there's your proof that the difference between the squares of any 2 consecutive integers is equal to the sum. Okay, let's move over to question number 21. So this is again a probability question. We have 10 pens in a box, and there are X pens in the box. And there are 10 pens in a box, and there are X red pens in the box, whilst the others are blue. We now know that Jack takes at random 2 pens from the box, and we need to find an expression for the probability that he takes 1 pen of each color. So we'll go ahead and draw out our probability tree. And again, I'm going to go with my red, which is going to be X over 10, and that's going to be my red, whilst my blue is going to be 10 minus X over 10. And that's because we're subtracting the X value, which is our red pens, from our overall 10 pens in the box. And then again, I'll go ahead and draw another 2 sections. And again, if we state that Jack picks out a red first, we then know we're going to have 1 less red overall. So we'll go ahead now and write that out. And that's going to simply be X minus 1 over 9, which is your red, whilst the blue is going to be the same, which is 10 minus X, but this time it's going to be over 9. So 10 minus X over 9. And now let's go for the second scenario. And that's where we pick out a blue first. So we know that the blue is going to simply change and decrease by 1. So that will be now 9 minus x over 9. However, the red will remain the same as x over 9. But notice that the denominators have changed and they've been decreased by 1 because Jack has picked out a blue this time. So let's go ahead and put this together. And we're now going to go with our red and blue, or our blue and red. So this is just in the order in which he has picked this. So if he goes for a red first, we're going to go for x over 10 multiplied by our blue, which again, in this case, will be our 10 minus x over 10. And we need to add this to our blue and red. And that's simply going to be 10 minus x over 10 multiplied by our red, which is x over 9. So again, what have we done? We've gone ahead and picked out our red first, and then our blue. And then we've gone for our blue first, and then our red. And that is just to cover all possibilities. So again, if I bring this one here, we're now going to have x 10 minus x over 90. And then if I go ahead and bring that one here, we're going to add this to x 10 minus x over 90. So then we can go ahead and simply expand the brackets and then simplify them. So we have 10x minus x squared over 90 plus 10x minus x squared over 90. And we can bring that into one fraction now, which then gives us 20x minus 2x squared over 90. And then we can simplify this by dividing both sides by 10, which gives us 10x minus x squared over 45. And that is our final answer, is 10x minus x squared over 45. So I hope that was clear how we could start off by working through by having 10 pens in a box and having x red pens. So then we know it's x over 10. And then that leaves us with our blue, which is going to be 10 minus x, which again will be red. So 10 minus the red, and you'll be left over with the blue. And then finding all the different possibilities of getting a red pen and a blue pen, or a blue pen and a red pen. Question 22. So this is a question around vectors. And we've been told that it's a quadrilateral and that x is on the point AB such that AX to XB is 1 to 2. So we know that gives us 3 parts in total. And we know A to X is 1 and X to B is 2. So let's go ahead and write this out. So we'll put our X here, and we know this is our 1 to 3 versus this, which is our 2 to 3. So now we've written that out, let's go ahead and prove that CX is equal to 2/5 of CY. So the first thing I'm going to do is take a look at the information they've given us. And we know we've got A to X and X to B. So why not try to work out the distance from A to B? So again, we've got A to B here, and we're simply going to go against the arrows, which means it's going to be a minus 3A and a plus 6B. So minus 3A plus 6B. And let's go ahead and calculate AB. In order to get from A to B, we need to go from A to C and C to B. And that's simply going to be minus 3A, because we're going against the current, plus 6B. And then we're going to calculate A to X. So now we know that A to X is simply going to be 1/3 of minus 3A plus 6B. So that's simply the journey from A to C and C to B, but 1/3 of that entire journey. And if we go ahead and simplify this, that's going to give us minus A plus 2B, because we simply go ahead and divide minus 3A by 3 and 6 by 3. So I've calculated my A to X. I'm now going to calculate my C to X. So again, my CX is simply going to be my C to A plus A to x. And that's going to be 3a minus a plus 2b. So now that I've gone ahead and done that, I can simplify this, which then will give me 2a plus 2b, before finally going to work out my cy. So let's go ahead and write cy. So how do we work out cy here? Well, the first thing we do is we need to simply start from our c and go to our b, and then from our b, go to our y. So let's go ahead and write that out. So our c to b is going to be 6b plus 5a minus b. So let's go back and check that out. It's going to be our 6b plus, because we're following the same direction, 5a minus b. And then again, it's going to be your c to b plus your b to your y. So now we've written that out, we can simplify this, which gives us 5a plus 5b. So now let's take a look at what we've got here. So now we need to simply prove that your c to x, which is what we had, which is 2a plus 2b, is equal to 2/5 of cy, which is simply 5a plus 5b. So again, if we take a look at this, we can go for 2a plus 2b, which is equal to 2/5 of 5a plus 5b. And again, what I've simply done is, if we have 5 apples here, 2/5 of that would be 2 apples. And that's simply how I've got my answer here. And that's your proof for this particular question. Okay, let's go over to the final question, 23. And this is now focusing on your gradient. So let's take a look at what this question says. So find an equation of the line that passes through C and is perpendicular to AB. So the first rule is to highlight your perpendicular. And what that highlights is that in order to find the gradient of two lines that are perpendicular, the product of the gradient must equal to -1. So perpendicular gradient must equal to -1. And remember, if two lines are parallel, that means the gradient must be the same. But in this case, we're focusing on perpendicular. So what do we do here? We start off by focusing on the change in y over the change in x. We're going to be passing from A to B. So let's go ahead and write down our A coordinates, which is -2, 0. So that's your x and y. And then our B coordinates, which is 0, 4. And that again gives us our x and y. And remember now, this is the difference of our change in y over change in x. So again, we'll do y2 minus y1 over x2 minus x1. And that's simply going to be your 4 minus 0 over 0 minus -2. So again, we know that gives us 4 over 2, which gives us 2 as our gradient. And remember, that falls back on our perpendicular gradient, that the product of our two gradients should give us -1. So let's go ahead and write out our equation, which is y equals mx plus c. But we know our m is now going to be -1/2. So how did I get -1/2? Well, as I mentioned, that gradient 1 multiplied by gradient 2, which in this case is 2, should equal -1. So we now know that if we take the times 2 to the other side, that will become a divided by 2. So then we know that our answer would be -1 over 2 will equal -1 over 2. Hence, that now is our x value. So that's our gradient. So let's go ahead now and complete this equation to find the value of c. So I know that my y equals -1 because of my third coordinate. 5 is my x and -1 is y. So I'll go ahead and substitute that in. So we've now got -1 equals -1/2, and my x is 5, as we found, plus c. So then we have -1 equals -5 over 2 plus c. And then we need to now make c the subject. So we'll take that, we'll add 1 on both sides. So now we have -5 over 2 plus 1. And this 1 can be seen as 2 over 2. So now if we go ahead and change this into a 2 over 2, minus 5 over 2 plus 2 over 2 will give us 3 over 2, which now will be equal to c. And then we go ahead and put this into our equation. So we've got y equals minus a half x plus 3 over 2. And that's your y equals mx plus c. And that's our final equation of the line that passes through C and is perpendicular to AB. So let's scroll down and write that out. That's y equals minus a half x plus 3 over 2. And that's 4 marks in the back. I hope all of my steps were crystal clear, and if there was anything that you found challenging or difficult, please go ahead and comment below and tell me the answers that you received. So that again was your Mathematics Paper 1 Non-Calculator Higher Tier Edexcel paper. I hope this was super useful. Please watch out for our next series where we'll be going through a range of different topic papers. I'll see you again. Thank you.